So something that's important for thinking about how to measure the performance of speech segmentation models like those using Bayesian inference, especially if we're talking about the early stages, the very early stages of speech segmentation, like what's happening at 6 months. So what a 6-month-old thinks are actually useful units to segment out of fluent speech may not be what we as adults think of as words. That is, or very early segmentation output may not look like adult words. So just as an example of this concretely, let's consider this utterance: see the kitty playing with the string. So a useful unit that's actually smaller than a word is that ing on playing, right? That actually is a meaningful morpheme, a meaningful unit that indicates an ongoing action. And so splitting up playing into play and ing over an over-segmentation error, so to speak, may not be so bad, right? Because you can actually learn something about ing and what it means and how it's used. As another example, we can think about the opposite of under-segmentation. Maybe the segmentation output puts the and kitty together to make the kitty a single word. This also isn't so bad because you know what, in terms of learning what that word means, the kitty is actually sort of a nice meaningful unit. It happens to be a meaningful phrase that maps to a specific concrete object, right? So it's still useful as a unit to segment out. So suppose, keeping this in mind, we allow the following to count as useful units, even though they're technically missegmentation. So ing, we say is okay, and the kitty, we say is okay. So an okay over-segmentation and an okay under-segmentation. So therefore, the comparison segmentation is that see the kitty as one word, play ing with this string, like these are okay to do. So if we go back to, say, a segmentation that a learner, a model has as an output, and let's say it did this: see the kitty play ing with the string, right? So if we look at recall, okay, well first it's always about true words. So how many true words do we have? Remember, we're comparing against missegmentations, that under-segmentation, the kitty, and the over-segmentation ing that we said were okay. So see is good, the kitty is good, play is good, ing is good, string is good. That's 5 true words when we allow in these useful units out of the 7 words that should have been found. So see the kitty, play, ing with the string, right? So that's 5 out of 7 on recall, which is looking pretty good. And if we look at precision, again, we have 5 true words, and of the units identified, see the kitty, play, ing with the string, only with the is wrong, right? So that's actually 6 things identified, 5 of which were actually useful units by our definition. So precision is 5 out of 6, which is really great. And so, for example, this is one of the reasons that we find that Bayesian inference, this particular learner we looked at before, works so well across different languages. When we count these useful units as reasonable segmentation output for a 7-month-old, Bayesian learners do really well cross-linguistically. They have an F-score of about 77%, which suggests that Bayesian inference, this kind of sophisticated statistical learning, may work quite well as a statistical strategy in the early stages of speech segmentation in the absence of other cues.